I'm James Sylvester from JPS Reliability. We're a specialist condition monitoring consultancy company based in the UK. We provide on-site traditional surveys, and also we specialise in helping teams get up to speed, enhancing their reliability through the use of condition monitoring technologies. Today I'm going to go over a case study from our Book of Gold, which is our recently published second book. So this one here came about from our first book. We had our first book, Enhancing System Reliability Through Vibration Technology, where we put into technicians' terms all the vibration gobbledygook, and at the back we had some case studies, and the biggest feedback we had from that book was people loved the case studies. Then we realised that there's a gap in the market, or a gap in training. Because I'm a trainer with RMS Training Institute, we deliver the Mobius and Bindit courses for vibration, ultrasound, soon to be thermography, and the ARP reliability courses as well for Mobius. And what we see is there's a body of knowledge which you learn to the ISO standards, but what people sometimes lack the opportunity to do is to get practical experience. So that's why basically we put this book together. So this book has got a dust cover on the front, and once you take the dust cover off the front, it's a traditional black gold leaf writing with a ribbon. So in this book is over 160 vibration case studies. We have vibration data, the history, and more importantly the strip down reports. So where you get someone doing their VCAT 2 who's been on site for 5 years, they got 5 years experience, but they only have 5 years experience at that plant. They've lacked the opportunity to go to other facilities, different industries, and this is what fills the gap. And if you sit the VCAT 2 public course with RMS, you get the Book of Gold as part of your training material. And likewise, when you do the VCAT 3 with RMS, you get Enhancing System Reliability, which is more of a technical terminology type book. Okay, so the first thing to remember is condition monitoring does not improve reliability. Condition monitoring alone is pretty darn amazing. You can predict faults, you can help production time, the downtime, you can stop major catastrophe, but it does not improve reliability. Reliability is improved when you take your data from your technologies and eliminate this defect or the failure from occurring again. So what the way to do it is basically, yes, we enhance the system reliability through condition monitoring technologies by applying a health-based maintenance. That is maintenance when it's needed, not when the computer says change it out because it's been 2 years. You change on an as needed basis, and every motor, every pump, every gearbox is all independent in their own environment. We improve machine and system functionability, i.e. keep it doing what it should be doing, so production can run for longer periods. But to do that, you need to determine the failure mechanisms in your asset. If you don't understand how your system can fail, you won't know what the indicators will be so you can detect a failing. So if you don't understand it, you're on the loser straight away. But when you do understand how things fail, you can apply the condition monitoring strategies, i.e. ultrasound, lubes, oils, wear measurements, airborne ultrasound, vibration, thermography. And from that then drives the maintenance tasks. So condition monitoring is amazing, but we must use this tool more and integrate it with reliability. I'm planning to go through 6 of the case studies from the new book. It's been a while since I did the last one because we've been pretty busy with our new guy starting, and it's been a bit manic, and obviously as you can see it's leading up to Christmas. So we thought we'd try and get another case study out there before Christmas, and then we can spend a few weeks with the families. So this one is on motor bearing sub-suface fatigue defect. Now this does beg the question in condition monitoring vibration analysis, how good is your crystal ball? Because whenever you find something, people will say, well, how long have I got? How long until it fails? How long do I need to do maintenance? And a lot of that does come with experience and time on the tools. But in our books, we've got some tables which will help guide you to make the right risk assessment or assessment of asset health. But more importantly is when do you want to find a defect? So we work for some petrochemicals where they only have a shut once a year. Now, we need to know way in advance if there's a slight more stress wave on that bearing, the outer race, the inner race, the cage is rattling, so we can, the client can put maintenance tasks in to keep it down and controlled to the shut. And then we have some clients which are more rough and ready, agricultural, where they just need to know it's going to fail next week because they have weekly shuts and they can plan it in. But the good thing about condition monitoring is you can get that lead time in advance. So you know way in advance when it's going to fail. So you can source bits, look at how long the bits are going to take, the effective downtime, planning, and that. Okay, that's a picture of the motor and pump. So in this case study, we were asked by the asset owners to do a full asset assessment because they had no idea what risks they had in their plant. They had a budget to spend, they wanted to spend it at the appropriate machine, so they got a good year of no risk. So we surveyed the pump, they gave them a list of action, and one of them that highlighted was we found an outer race defect on the motor, which we'll go through why we think it happened. We'll show you the bearing as well. But this highlights that to perform one-off assessment, you need to be a seasoned analyst, you need to be experienced, or you need to have someone supporting you remotely or in your team who can guide you and you can learn from. Okay, this here is the vibration data, the peak view data. And one thing we did notice on this, that actual plot has got the 2x live frequency, pulse frequency removed. If you see up there in the top, right, it's got peaks removed. Because this harmonic series we found with the software, but it's really low. So he took out the electrical noise and we can see a clear, lovely, exponentially decaying down, which matched the outer race. Okay, so we were pretty sure we had an outer race. And as they wanted to know if it lasts a year, we had a look at other assessments, because you don't just make an assessment on peak view alone. Use other technologies or other parts of vibration access. So we looked at the velocity, and even as though you can see in the velocity here, we had outer race signal and lots of noise in the velocity data. Now that shouldn't be there. So we thought, well, it's doing something. It's definitely an early defect. Pardon me. Now, the acceleration was a giveaway. You can see here we got a low level outer race signal coming up and a big mound of noise, which is side binded by the 2x pulse frequency from the drive. So that's whatever hertz the drive is putting out times 2 because of north and south. And that is a dead giveaway for electrical issues. Now, electrical issues is a really big, huge thing. Everyone's going to variable speed drives, and we're finding a lot of installation anomalies. So this could be down to incorrect earthing, no earthing, poor earthing, lack of greasing, lack of maintenance of the drive. Now the drive itself alone is not an issue. It's how the drive is fitted to your system and the cables you use and the screening. Okay, so we strip the bearing down. Now what I'll do is I'll grab the bearing now so we can have a look at it. But the first thing we notice in the bearing was this blackened type grease. So what that is, basically, with that electrical noise we had in the data, and we had the outer race signal and peak view and velocity, we can say, without even stripping the bearing, that, yeah, look, we think you've got EDM damage, electrical damage to your bearing on your outer race, and the blackened grease is a dead giveaway. Reason being is the high frequency noise should go back to your drive and then down to back to the transformer, to the earth. But it finds the easiest way out, and if you don't have the correct screening, earthing or protection, it builds up, and it just builds up like a pasta and arcs for your grease and kills your grease. Right, what we'll do is we'll jump now and have a look at the bearing and some of the tools we use. Then we'll come back and finish off this part of the presentation. Okay. Okay, what we're going to do is we're going to look at the bearing now, and with the vibration data we picked up a little defect on the outer race. So first of all we look at the inner race. Now I don't catch this in the camera, but here, around here, see it looks like burn marks. all the way around, and they're like juddering. Okay, see that? Little burn marks. Try and get it focused in. There. Now, those burn marks, you can imagine, with the common mode voltage in the drive, which is created from the way it makes it a variable speed drive, and the pulse width modulation makes like a saw wave. So these burn marks are the start of before we gonna get like the railway track. So that's very, very early EDM. Okay. Now, another giveaway for if you've got drive problems or challenges is, look, if you look at the rolling element here, you can see it's like shiny there, okay, but then look, see this bit here? It's got a row of dullness. So that dullness is the electrical high frequency current, noise, whatever you want to call it, trying to get back to your start point, your transformer, and it's the quickest way is through the grease and through the bearings. So yeah, so you get that shiny and dullness. Now, because it's obviously out of raised bearing, she's stationary, we'll have a load zone and a non-load zone. In the non-load zone, all the way around the bearing, you can see a tiny little grey line. So that grey line is, again, issue with your drive, or that's not the drive, issue with the earthing and the setup of the drive. And the actual defect which we predicted, you can feel it with your fingernail. So as it comes into the load zone, it gets thicker and thicker, and it is there. So it's really hard to capture it, but that there is what we'll see in a minute on the close-up images with the microscope. So that there is the defect, and a little picky, you can pick it, so it's just before it's going to spawn come out. So vibration acid is amazing if you understand what you're using and what you're finding, and this is a great example of picking up a subsurface defect through vibration analysis. Admittedly, not all applications and all clients will want you to pull a bearing, because if you pull a bearing like this, they'll just laugh at you and go, where's the damage? But this client is critical that they had a year operation out of the asset. Other clients, you could monitor, grease, trend, and as it starts to increase and the risk comes up, then you would do a change out. Now, this is a great example of drive issues where it's incorrect earthing or ground into the drive. And what we found is in the vibration data, it easily shows you there's a drive issue, because at your 10 kilohertz, up high frequency, high sample rate, you see a mound of activity, usually 3,000 to 5,000, side banded by the 2-time pulse frequency of a drive. Lots in our first book about a drive, we actually did a section on variable speed drives in our first book. But what we got as well, so when we're also out, we see it in the VA, and we know there is an issue, we use a SCEF counter. So you can actually use this and you can move around the motor, and what we've had before is we've gone down the motor cable and picking up high frequency discharges all the way down to the motor, and on one particular motor there's nothing under the non-drive end, and when we look at the data we could see high friction levels. The next motor we come down all down the cable under the back end of the motor and we were getting counts, and we looked at the VA data, clear defect. So that motor had been running longer with the drive issue or the setup or the earthing issue, which has caused these defects. There's another tool we use, I'll just grab it, for actually doing electrical testing. So this one, we do the VA, we see there's a defect, we scan with this and we go, yep, confirmed it. But to actually get a physical count of it, I'll just go and grab the other scope we use and show you. Okay, so the scope we use is we use a shaft riding carbon, like a little brush, like fibres. So it's clean. We clean the shaft up. And we put on a magnetic stand, start the motor up, and that then makes contact with the shaft, which gets plugged into the scope. And the other end of the scope then goes into the earth. So this is the scope, and what we can actually do, you can actually measure and quantify in a waveform the discharges, and it's a super fast scope, so we can pick up those defects really early, and it quantifies it. And there is a rough guidance of how much volts discharge will give you damage, and some assets you can grease it more, technically over grease it, but you keep the damage down and you can make it long last to shut. What we'll do is we'll look at the close-up images of the bearing now. Okay. Hi, welcome back. So we've looked at the bearing and we looked at the tools which we can use to additionally quantify this electrical anomaly. And what you can see here, if you see that grey band coming up and down, well, it's getting thicker in the low zone of the bearing. And that grey frosted is from the common mole voltage from the drive. And as we showed you, because that tiny little pick, that little fleck in there. And if we zoom in to the fleck, you can see here, a little bit of spot welding, and it's all subsurface fatigue, so that's going to crack and that's going to pop off. So this does prove, and if you measure the correct technique in the correct way, you understand your assets and the failure modes, and you set up correctly, there's no reason you cannot find a subsurface defect in a bearing. The big question is, when would you want to do that? Well, we do it as standard all the time, but then the follow on from this is depending on the client's risk and how far they want to change out in advance. So here you can see that one there. So the summary of the findings, yeah, don't just use one technology within vibration, use all the technologies. Use your eyes, strip the bearing down, look at it, look at the lubes, look at the oils. And this type of action does prevent any secondary damage. And one key thing is, we've proven that there's electrical defect and electrical noise was killing the grease, but you mustn't forget all that electrical harmonics is just also killing your insulation on your windings. So it's a bigger thing than just the bearing health. It's a whole motor reliability, which, as I said, we work with Mark Gurney from PHY in the motor reliability sector. So the likely cause of this was subsurface initiated defect due to normal cyclic load in the bearing. It had reached its end of life in this application, but it was due to the drive. So a little reminder of our book, hardback, dust cloth, gold foiling, got a dust jacket on it. We went a bit overboard and picked the thickest paper we can, the glossiest paper so it can be kept clean. We got the end pages, A4. It's quite a heavy book, and 116 VA, and at the very back we got some of the thermography. So we also do thermography, and what we've done, we've picked out 18 different failure modes in thermography and put them in the back as well. These are current stockists, which are growing month by month. Obviously you can get it from us direct. Our main one in the UK is Reliability Maintenance Solutions, which have this Book of Gold on their VTAC 2 courses. Free high reliability in Europe, and we've got Nora in USA, Latin America, Frederick Reliability Solutions down in South Africa, and Premium Protective Engineering, which is a training company in Iraq as well. Well, we hope you find this interesting and it's helpful. Don't forget, go and get yourself a copy of the Book of Gold for Christmas, and I hope everyone has a lovely time with their family, and we will see you in the new year. Take care. Bye.